public company are lagging behind, so let's see if we do. We are a public company, we are a grid operator, and we connect households and industry to the electricity and gas grid. We do that for roughly 3 million households, we do that for roughly 100,000 organizations, and we have a downtime of 19 minutes annually, which is pretty good actually by any standard. We would like to keep the downtime this low or even lower, since Europe wants energy to be available all the time for everyone at low cost, since then we can also compete with China and the US. Now, having said that, there's all sorts of things happening in the energy landscape, and a few of these are following. There's electric vehicles. Anyone has a clue how much energy an electric vehicle consumes? No? About 7 households worth of energy. So if you come home at 6 o'clock and you plug in your EV and your neighbor comes home and everyone comes home, then out go the lights. Our grid has not been designed to do this sort of capacity. Our grid has been designed maybe 100 years ago, 80 years ago, 60 years ago, and it was meant to have a light bulb in your house burn the energy from one big central that was somewhere else. So there was one-way traffic. Now people start to produce energy themselves. They start to store energy themselves. They start, even worse, to deliver back to the grid what it was not designed for. So what happens is, if the sun starts shining, there will be an influx of energy in the wrong direction instead of the energy flowing to your homes. We will have smart meters. We have to roll out smart meters in the country. We have 3 million customers. We have to roll out 5 million electricity and gas meters. And these will be connected to our company in some way because they will send us all the data of your consumption. This is a few initiatives. Then cities do want their lighting, for example, to reflect the atmosphere that's in the city. So if there's a festivity going on, they maybe want dimmed lighting. They may also want lighting to just go on and off if motion is being detected. So there's more and more smart ideas about the whole society, and the city as a living organism reflects in the way they want their energy to be consumed, which means there will be more and more points of connection to our grid that will start to interact with our grid. Finally, if we add up all these initiatives, we arrive at a smart grid, where all the connected devices, your Internet of Things at home, your smart meter, your electric vehicle, will have to communicate or else blow up our grid, or we will have to enlarge the capacity of the grid, which will set us back roughly 10 billion euro. I don't know about you, but we seem to have a bit of trouble finding the money. This is the pressure. We're supposed to keep the minutes of perturbance down per year, and while you buy your electric vehicles and start producing energy during daytime as the sun shines, and you start consuming it like hell in the evening when you plug in your EV, and your TV and your washing machine, we have to manage that the grid doesn't go down, you don't put your neighbors in the black. So that's why our CEO says that when the sun goes up and the wind blows, the lights will go out. Not nice if you're a grid operator. This is one of the few points that we're faced with. Potentially, we will have millions of access points to our grid, being you, the user of our energy. So we also have millions of potential hacking points on our grid. We also have a legislator that wants us to be very careful with the data that we process. We have data of you, the user of energy, and we have data of our staff, and the EU is getting pretty strict about what you're able to use and what you're not. So if we violate a law or a directive, and you as a public person, you want to sort of sue us, you're welcome, and anyone can do that. So we have 3 million potential people suing us for any problem that we cause with their data. So we have to be very careful there as well. There was a mid-voltage generator, transformer, blowing up. And that is what can happen if people don't know what they do with mid-voltage. They are very, very powerful. This was in the States. It was an accident somewhere in Florida. It was not because your 14-year-old came home drunk and he asked, what does this button on your iPad do? It was really a mistake from the people themselves, and it had not been maintained well. But it's something that can happen if your smart meter is being hacked and in some way you arrive at our grid, which is something we would like to prevent from. So these are a few constraints that we have to operate our business. We have been declared to be vital infrastructure, because if things are getting rough in a country and there's also no energy and no utilities, then the cohesion of the people start to go down. So we're sort of noticed that we have to keep things up, even if there's a war going on or if there's terrorism or whatever. So that means that the places where we have, let's say, the upside of risk for cloud and virtualization are maybe not as abundant and as in any company that you operate from a commercial perspective. So where do we see it? I don't know, anyone know this one? Simon Wardley, no? This is what happens with the average new goods and services when they enter the market. They go from birth and then they get accepted, and then more people get accepted and it gets nicely profitable. And then they get commoditized because more and more entrants are on the market, and prices will deter, and the prices will go down like this, and it gets very democratized until it has no more added value, and the value is like zilch. So enter the open source and enter all sorts of business model on low-cost income generation. Now, if we look at this one, and we look at where we see clouds, then you see that the things that are on the right end of, for you, this one, right end of the spectrum, these are the commodities. And what happens if time progresses, more and more things happen to go down from the upper right to the lower left as they commoditize over time, and then as they are commoditized, they're usually repackaged to something new like a service. And then on that new service, new possibilities arrive for anyone who wants to deploy it. So if you want competition to get going, then what you do is you make something, you make it open source, you throw it into the community so that people will adopt it and will start competing on what you give them. So, and then it flows back to you in lower cost. Now, compute and storage is slowly going to the lower left end and slowly becoming more and more commoditized, actually becoming almost a utility, which is something that is always there and you only notice if it doesn't function. So they get repackaged, and then it's called cloud now, or it's called virtual data center. In comes one of our managers after a weekend of golf, and he asks us, why don't we have a virtual data center? Everyone else has it. And then the answer starts with something like this. Recognize this? This is where we came from 8 years ago. Now, if we were to put this in the cloud, that would be a horrendous job, really. You cannot just take any part and move it because you take 30 plus interfaces, no matter what you pick. And we're a 100-year-old company, so there's legacy of ages you don't want to know. We only do not have IT type of hardware and software. We also have operational technology. You saw the transformer. We have a grid of electricity and gas. Electricity grid is about 100,000 meters of kilometers of cable and about 40,000 kilometers of gas tubes. And these are monitored by SCADA, which is also not the most modern type of, I would say, information technology. And most likely, it will not be connected. These are the lower three until number 3 there, will not be connected to IT. Because if we connect your smart meter to the IT network to gather your data, and we connect our IT network to our OT network, then chances of hacking an ICS system are pretty big. So the art of isolation is really here. And in order to do that, we have to make sure that we make a wise decision on what things we place where. So there's an enormous zoning and siting action going on in our data center. We have own data centers. We do cloud. And as I told you, that there is a lot of things happening in the energy world. There's also startups that we have, and we have new participations, so there's roughly about 30. Now, they all have a different place where cloud or virtualization comes in. And if we want to deploy that, we want to deploy it in a place where it adds value. So for a startup, it makes sense to deploy a DPaaS, for example, to get their development of their new business done in a very efficient and cost-efficient manner and be up to speed really fast. For our operational technology, I don't see any virtualization of SCADA coming in very soon. Maybe the HMI, but not the communication and not the devices itself. So, and I don't like the idea of it being coupled in a cloud service being somewhere else or even out of Europe. So that's not going to happen. If you look at these dependencies, you see six potential applications. Now, if you have 6 potential applications, you have 6 faculty potential number of interfaces. Anyone know the faculty of 6? 720. If you can make the problem smaller, then if you can divide it by 2, you have 2 times the faculty of 3, which is 6 and 6, as the total potential number of interfaces. So if we're able to segment the problem space into software that is working together in a manner that we have minimum interfaces with the outside world, as you see here in the picture, then we make our lives a lot easier. But can we find this in cloud? Well, for some things, we can easily find, for example, an HR system out there which will host our PeopleSoft environment nicely. But then again, there's 30 interfaces to PeopleSoft, and it feeds our AD, so is it wise to put that in the cloud? We don't know, but we'll try. And by choosing a cloud provider, you choose a lock-in. Lock-in games come normally over 2 axes. The one being that there is a switching cost, and the switching cost is what you pay to get away from one vendor and enter the next one. And that may be you have to take your data out, so there you must be allowed to take it out in a normal format and not this big blob, and to convert it to the state where you can enter it in your new system. Now, there's a whole lot of games that people play because as software, hardware commoditizers, they have to make sure that you're not leaving too early before you become profitable. And there's this very well-known bargain and rip-off scheme, and they will offer you the entrance at the bargain, and then when you're a customer and you're locked in, the prices will tend to go up, and then try to get out. And that there will be new and other services offered to keep you in. So, well, being, again, a national grid operator and being vital infrastructure, things that are our primary operations, I don't see ending up in this sort of game. Things that are normal IT business, like ERP or finance, who cares? So what do? We minimize the problem space by finding sets of software that work together and they have the most of their interfaces between them and little or none interfaces on the outside. And usually on, let's say, world-class standards, so that it doesn't really make that much difference what they speak, be it an API or be it a RESTful type of interface or be it file transport, but let it at least be a world standard. And the second one is that we look for the sweet spot in where we can place this type of functionality in the cloud. Now, that means we found a scheme to optimize, on the one hand, for our startups, because they're actually totally free to do whatever they please. They operate no operational technology. There is no risks of transformers blowing up. There is no risk of, let's say, you being in the black. But it doesn't stop our traditional business from being very, very careful in planning how fast and how we go to the cloud. Which brings me to a few takeaways that come from us as a public company. That is, anything that you find there is commoditized new developments. And really use it as a commodity because it will the biggest value to you as it is a commodity and low pricing exists. If it is still high up here in the scheme, you will end up paying premium prices. So what's the point? The other thing is, if you have your data center, then you can make the deployment of your servers, you can make that higher. But if you have to do that for just a handful of servers, you just increase the complexity of your data center and the cost of operating it. So be careful with the scale that you do this sort of initiative on. And the other one, and the final one, is really, we have been fooled several times with lock-in games. So I really would like to urge you to be very alert to the schemes that lie behind all these friendly offerings that you get. Thank you.